Today we're going to take a look at section 6.6, which is talking about rational exponents. And if you remember what a rational number is any number that can be written as a fraction. So today with rational exponents, we're going to look at exponents that are fractions. And actually you've done a little bit of this before back in section 6.4 when you evaluated cube roots and fourth roots and fifth roots. And kind of the idea that we looked at was what's another way to write the square root of x? Another way to write the square root of x was x raised to the 1/2 power. What's another way to write the cube root of x? X to the 1/3 power. And so on and so forth. If you remember, this little index number here became the denominator of the fractional exponent. The third root was the 1/3 power. Okay? If I had the fourth root of x, it's x to the 1/4 power, and so on. Okay? And we could also go backwards. Okay? We'll do that here in a minute. But what if I had the sixth root? Oops, sorry. That's not what I want. What if I had x to the 1/6 power? We could rewrite that as the sixth root of x to the first. So again, going a little bit back and forth. Okay? A little bit different today for my video here. What we're going to do is I have a little worksheet that if right before you clicked on this video, there's a little attachment there. That's a worksheet that we're going to do together, that I'm going to go through together with you on the second part of this video. So if you need to, like I mentioned in the directions, it might be a good idea to print that off real quick so that you can fill it out and go through this worksheet with me. So if you need to, push pause, go print that and come back, and then we'll continue on here. Okay. In the meantime, I'm going to set up my overhead here right next door and keep on going. Okay, so if you need to, go ahead and print and come back in just a minute. Go. Okay. So here we go. Let's see if this is going to work. Okay. So if you were able to print that worksheet, okay, the first page that we're going to look at looks something like this. Okay? And it says to write each one of these things in radical form. And I know there's kind of a bright glare here right in the middle of that somewhere. I'm going to try to work around it best I can. Okay? But the first one says we're going to write each of these in radical form. Now x to the 1/3, this is going to be very similar to what I talked about over on the smartboard here a minute ago. The denominator becomes the root. So this becomes the cube root of x, or x to the first. Okay? The fourth root of 16. Okay, so it's written in, well, we'll see on the next page here, but I'm going to do it also right here. If I write it in radical form, and if I can simplify it, let's simplify it. Is 16 a perfect fourth? Okay, another thing that's going to be really helpful is that little half a piece of paper that has the perfect cubes and fourths and fifths on it. Again, I should have mentioned this a minute ago, but if you have that, please go get that also, or grab it handy, because we're going to use it a lot today. Okay? But 16 is a perfect fourth. If I go to the fourths and 16 and I go across to the left, the fourth root of 16 is 2. Okay? This means the square root of 9, well, I know the square root of 9 is 3, so I can evaluate that as well. Okay, I'm going to look at number 4 here. The next one, I'm going to scooch this up a little bit. When I look at number 4, it says the fifth root, the 1/5 power, 4x to the 1/5 power. Well, that means the fifth root of something. And if you look closely, the 4 and the x are in the parentheses. So both the 4 and the x should be underneath the radical. The fifth root of 4x. This one now is a little bit different. What's being raised to the 1/4 power here? It's just the x. The 5 stays outside the radical, and this is only doing the fourth root of just the x. Okay? On number 6 here, when I have a power to a power, if I use my properties of exponents, I multiply them, I get x to the 5/2 power. Okay, well my goal here is to write it in radical form. Well, my denominator is a 2, so that means it's the square root of x, and it's the square root of x to the 5th power. Okay, so the 5 is under the radical, the 2 is out in front. It's the root. Okay, these last couple ones here, okay, now they have some negative exponents. You guys remember from before, we don't like negative exponents. Not allowed to have negative exponents. And what we did with a negative exponent, if it was negative on the top, it moved down to the bottom and became the positive 1/2 power on the bottom. Well, can I rewrite that 25 to the 1/2 in radical form? Well, it's the square root of 25. Okay, and the square root of 25 is 5, so that would simplify down to 1/5. Okay, same thing with this guy. A negative exponent means it has to go to the bottom, so it's 1 over 216 to the 1/3 power, which is the cube root of 216. And again, if I grab my handy dandy little sheet here and I go to the cubes, 216 and to the left, the cube root of 216 is 6. That one simplifies to 1/6. Okay, and one more here, 8 to the negative 1/3, well that has to go to the bottom. So it's 1 over 8 to the positive 1/3. 1/3 power is the cube root of 8, and the cube root of 8 is 2. Okay, so again, we did a little changing from fractional exponents to radical form. And the big thing to remember is that the denominator is the root. The denominator is the root. And so on. Okay? The next ones we're going to look at here at the bottom of this worksheet is it wants us to change these into exponential forms. We're going to go backwards. We're going to go the other way around. Okay? So in that first one, if I have the 4th root of x, well, if you remember, the 4th root is the 1/4 power. It's x to the 1/4 power, or just x to the 1/4. You can have the parentheses. You don't need to have them. Either one's okay. Okay, when I look at this one, I see a 5th root of y squared. Well, that's y squared to the 1/5 power, which is y to the 2/5. Whoops, that's not going very good. Okay, and some of you can kind of skip this first step if you want to, but you can see 2 divided by 5, the 2/5. Okay, same thing over here. This is the 4th root, so 9x to the 5th, y to the 6th is all being raised to the 1/4 power. And since they're all under the radical, all of them are in parentheses. And then if I distribute through, I get 9 to the 1/4, x to the 5/4, and y to the 6/4. And as we always do with fractions, no matter when and where we see them, if I have one that can be reduced, 6/4, I should do it. I can divide them both by 2, and I get y to the 3/2. And there would be my grand finale answer right there. Okay? On number 4, now look at that big 3 out in front. This is just a multiplier. It's not the cube root. It's 3 times the square root of that stuff. Well, the square root is the 1/2 power. And if I distribute it through, I get 3x to the 1/2, y to the 3/2. And if I look at those fractions are simplified, so we're done. Okay? And this guy right here is 625x squared. The 4th root is 1/4 power. And again, if I multiply it through, 625 to the 1/4, x to the 2/4, and then let's simplify it if we can. How about 625? Is that a perfect 4th? If I go to the 4th and down to 625, yeah, its 4th root is 5. 5, and then x to the 2/4, that's the same as x to the 1/2. So it's 5x to the 1/2 power. Okay? So we have a little practice on this first page going from radical form to fractional exponent form and vice versa. Okay, on the next page here, we're going to concentrate, and we did a little bit of evaluating, by the way, too, kind of like this right here. On the next page, we're going to do some more evaluating of these. And again, this is something we did back in section 6.4. Excuse me. Only we're going to try to do it this time without the use of your calculator. Okay. Now, again, ultimately, yep, you could type in 32 raised to the parenthesis 2 divided by 5 on your calculator and spit out a number. And hopefully it's a nice number. Okay, but I'm going to try to get you to do it without the calculator and with this little half a sheet of paper here. Okay, so let's see. It's going to be easiest, I think, if we put this in radical form. This means the 5th root of 32 squared? Well, let's see, is 32 a perfect fifth? Okay, and if you go to your fifths and 32, it's on there, it's 2. So it's 2 to the second, it's going to tell you 4. Okay. Same thing with this one. I see a denominator of 3, so it's going to be the cube root of 27 squared. Well, if you know this, you probably know this one. The cube root of 27 is 3, and 3 squared is 9. Okay, so it's almost faster to do it with your yellow sheet than it is to type it in on your calculator. Okay, I'm going to scoot this up a little bit. Let's try numbers 3 and 4. Okay, number 3 says the cube root of 216 squared. Oops. The cube root of 216 squared. Well, again, I go to my yellow sheet, and I go to my cubes and down to 216, and over to the left it's 6 again. The cube root of 216 is 6, and 6 squared is 36. Okay, and being able to do this with the yellow sheet or the half a piece of paper is going to be helpful here in just a few minutes. Okay, here's a negative 1. So that means it has to go down to the bottom. It's 1 over 81 to the 1/4. That's 1 over the 4th root of 81. Is 81 a perfect fourth? If I go to my fourths, there's 81, and I go all the way to the left, it's 3. The answer is 1/3. Okay, and for those of you who are doing these on your calculator, just so we're all crystal clear, I don't want the decimal. I want the fraction as an answer. Okay, there's 2 left on this page. I'd like you to try them. Can you try numbers 5 and 6? We're doing the same thing. Okay, take a minute, push pause, try it, and then unpause. And we'll see how we did. Okay, ready, set, go. Okay, if I look at 16 here, the 2 is the denominator, so it's the square root of 16 cubed. Well, the square root of 16 is 4. 4 cubed is 64. You can do 4 cubed with your calculator, or again, you can do 4, go over to the cube, and it's going to tell you 64 as well. Okay? This guy is the 4th root of 256 to the 3rd. If I use my yellow sheet, the 4th root of 256 is 4. And again, 4 cubed is 64. Okay, so we got the same answer 2 times, but 2 different problems. Okay, all right. Next page, they're going to have us do a little bit more simplifying. And they have some rules here that I think we've talked about some of these before. Okay, when we simplify these are some things to keep in mind. Okay, we cannot have any negative exponents. We already know that. We can't have any fractional exponents in the denominator, because in the denominator, if it's a fractional exponent, it's a radical. Okay, we're not allowed to have radicals in the bottom. Okay, and we'll see here later on, especially that if the problem starts in radical form, our answer should be in radical form, and vice versa. Okay, let's take a look at these first 2. Okay, these practice problems are essentially going to involve the properties of exponents that we learned a while back. Well, we've done this one, x to the 2nd times x to the 3rd. We add the exponents, it's x to the 5th. Okay? Well, what if the exponents are fractions? Do you do the same thing? We sure do. 2/5 plus 1/5, that's x to the 3/5. And it's good news, since the fractions had common denominators, we can just add them. That's a good thing. Okay, sure. Okay, can you do anything with 3/5? No. That's simplified as much as we can. Okay, but I'm going to put the next 2 up here. Okay, oops. How about these 2 right here? X to the 2/3 and x to the 3/4. Uh-oh, bad news. They're still being multiplied together, so we're going to add our exponents, but the denominators on the exponents are not the same. Okay, so we need to do 2/3 plus 3/4. We need to find a common denominator. If you know, the common denominator of 3 and 4 is 12. 3 times 4 is 12, so 2 times 4 is 8. 4 times 3 is 12, 3 times 3 is 9. And if I add them together, I get 17/12. So I get x to the 17/12. But the key there is we add the exponents together. And is that something you could add those two fractions together with your calculator? Sure. Just make sure you change it back into a fraction. And 17/12 is as far as we can do. Okay, how about this one? Same thing. I'm going to have 3/5 plus 1/2. Bad news, the denominators are not the same, so we need to find a common denominator, and it's going to be 10. 5 times 2 is 10. 3 times 2 is 6. 2 times 5, 1 times 5 is 5, and if I add them together, I get 11/10. Okay? And so I'd get x to the 11/10 power. Hang on just a second. Okay? And if you look at 11/10, it can't be reduced, it can't be simplified. That's as far as we can go. Okay? All right, there's two more here. We're getting there, we're almost done. Okay, what about when you have exponents on the top and exponents on the bottom? We saw one of these when we did the properties of exponents a while back as well. Okay, what do I do when I have 7 x's on top and 3 on the bottom? We subtract them. 7 minus 3 is 4. And the bigger number's on top, so I get x to the 4th on the top. Okay. How about with fractions? Can we do the same thing? Yeah, we're going to subtract them. Notice the bases are the same. So I'm going to do 4/5 minus 2/5. Good news, the denominators, we have a common denominator, so if I subtract them, I just get x to the 2/5. 4 minus 2 is 2. Bigger numbers on the top? It's on the top. And 2/5 is reduced, and that's as much as we can do. So the same properties of exponents that we learned a while back apply to fractional exponents as well. Okay? I just have a couple others here real quick. Okay, more along the same lines. Here's another property of exponents. We briefly talked about this on the first or second page today. What if you have a power to a power with parentheses? What do you do with those exponents? Yeah, you multiply them. Okay, if I multiply here, I get x to the 3/8. Okay, and 3/8 is simplified. We're done. How about here? Negative exponents, but I have a negative times a negative, so I'm going to get positive, and I'm going to get positive 3/20. Okay, and that fraction is simplified. That's as far as we can go. But number 9 and 10, they have little stars next to them, because we're into a little issue here. I have a negative exponent. Well, that means it has to go to the bottom. Okay, and one of the rules on the previous page said, we can't have exponents, fractional exponents on the bottom. So how do you get rid of them? Okay, well, what we're going to do is before, just like we did with i's and conjugates and radicals like that, we're going to multiply the top and the bottom by something. And what I want to have happen is I want the denominator, the fraction on the denominator, to go away. And the way 5/6 is going to go away is we're going to try to make 5/6 become a whole. We're going to try to make it become 6/6. So what would I throw it out there? You guys know what I would multiply by to make that 5/6 turn into a 6/6? How many more does it need to become a whole? It needs 1/6. So what happens if I multiply by b to the 1/6 over b to the 1/6? My numerator is going to be b to the 1/6. But the denominator, when I add these fractions, I get 6/6, which is just 1, or a whole. And voila, there's no more fractional exponent down there in the denominator of that fraction, and we're done. Okay? Same thing with this guy. Okay, this has to go down to the bottom, w to the 3/5. Can't have fractional exponents in the bottom. So I need to multiply the top and the bottom by w to some power. Well, how many more fifths do I need to get here to make it become a whole 5/5? I need 2 more. W to the 2/5. W to the 2/5. Okay, and if I keep multiplying, my numerator is just w to the 2/5. The denominator, 3 plus 2 is 5/5, which is just 1, or a whole. And there we have it. Okay? So again, if you have a fractional exponent on the bottom, the way you get rid of it is you multiply the top and the bottom by however many more you need to make it to become a whole. Okay? All right, and here's the very last things. These are special ones. Okay? We're going to try to simplify each of these. Okay? And the first one here, the cube root of 64z to the 6th. Okay, well, we've kind of done something similar to this before. if I look at the number part, the cube root of 64, if I just did this part by itself, is 64 a perfect cube? If you looked at your sheet, yes it is. The cube root of 64 is 4. Okay, so that turns into a 4. And then how about the cube root of z to the 6? If I did 6 divided by 3, I get z squared. It's probably the fastest and easiest way to do that one. Okay, we'll call it good. Okay, well, let's take a look at the next one. The 6th root of 81, g to the 3rd. Okay, now bad news. 81 is not a perfect 6th. If you look down here, down to your 6's, 81 isn't on there. Uh-oh, so now what do we do? Okay, well, the first thing that we should do is let's change this. Oops. Let's change it into fractional exponents. It would be 81, come on here, 81 g to the 3rd, all raised to the 1/6 power. Okay, and if I kind of did this, it's going to be 81 to the 1/6, and then g to the 3/6. Well, 3/6 is 1/2. I'm going to simplify it. Okay, the g, I can't do anything more with this. But 81 to the 1/6, and here's the crutch or the whole key to these things. What we need to do is we need to rewrite 81 as something else, as a different form, in a different form, raised to the 1/6 power. Okay, what we want to do is we want to try to find the smallest number that can be raised to a power to give us 81. And I see 81 is right here, and it's 3 to the 4th power. So, and again, this is the big thing. I'm going to rewrite 81 as 3 to the 4th power. And then I'm going to multiply my exponents. That's 3 to the 4/6. If I simplify it, that's 3 to the 2/3 power. Okay? So I change my 81 into 3 to the 2/3 and g to the 1/2. 2/3 is as far as I can go in terms of fractional exponents. But, last thing here, the problem started in radical form, so I need my answer to be in radical form. How do I change 3 to the 2/3 back to radical form? Well, it's the cube root of 3 squared. Well, 3 squared is 9. So it's the cube root of 9, and then the g part, it's the square root of g. Whoa, that's pretty hardcore. That's how that one simplifies out. Okay? But this whole key, and we're going to practice a couple more of these, changing 81 into some number to a power is going to be the key. And again, this little sheet is going to be really helpful with that. Okay? All right. Got another pair here. Scooch this up. Let's try these. The 4th root of 64 is the first one over here. Now, if you look on that little half a piece of paper, 64 is not a perfect 4th. Okay? So what we're going to do, well, first of all, I'm going to rewrite this as 64 to the 1/4 power. Okay, and it's not a perfect 4th. 64 is not, so I'm going to try to rewrite it as something else. Okay? And again, if I find the smallest number that can be written as 64, it's 2 to the 6th power. So I'm changing 64 into 2 to the 6th power. And all of that's being raised to the 1/4. Well, that's 2 to the 6/4. And if I reduce my fraction, it's 3/2 if I divide them both by 2. Okay? Now, just like on the last one, it started in radical form, so I want my answer in radical form. It's going to be the square root of 2 to the 3rd power. And 2 to the 3rd power is 8. So my answer is the square root of 8. It's almost my answer. Can we simplify the square root of 8? We can do the square root of 4 and the square root of 2, which is 2, so I get 2 square roots of 2. Okay, this is getting pretty hardcore, pretty complex. Okay, but it all started by changing 64 into 2 to the 6th, and then it's just working with the radicals and the exponents. Okay, let's look at number 4 here. We're almost done. Okay, 27 is not a perfect 4th, and neither is 3. Okay, so I'm going to rewrite this as 27 to the 1/4. I'm going to write it in fractional form. And 3 to the 1/4. Okay, now since they're both being raised to the 1/4, I could do this. 27 over 3, both raised to the 1/4. And 27 over 3 is 9 to the 1/4. Okay, so again, this really means just the 4th root of 9. Doesn't help me. So I need to rewrite 9 as some other number. Is there another way I could rewrite 9 as some number to a power? Some of you know that 9 can be written as 3 to the 2nd, 3 squared. If I multiply my exponents, that's 3 to the 2/4, or 3 to the 1/2, which is the square root of 3, is what I would be looking at on that one, just the square root of 3. Okay, but again, the key was changing 9 into 3 squared. Okay, one last problem. This is it right here. Okay, and again, it's just practicing these. The more you practice it, the easier it's going to become. So here we go. Here's the last one. Okay, and we're hitting pretty much very, very, very similar types of problems that you're going to see in your homework. So if you get stuck, hopefully this video will allow you to come back and revisit some of this. Okay? So I have 81, the 8th root of 81 and the 6th root of 3. Neither one of them are perfect 8ths or perfect 6ths. Okay, but I think the first thing we want to do is rewrite it as a fractional exponent. And 3 to the 1/6. Okay, so 81 to the 1/8, oops, and 3 to the 1/6. Okay, well, 81. 81 isn't a perfect 8th, but is there another way we could rewrite 81? And we did it earlier. We want the smallest number that can be written as a power to give us 81. And if you look across here, I think you'll see 3 to the 4th power is 81. So I'm going to rewrite 81 as 3 to the 4th. And if I keep going to just my numerator, that's 3 to the 4/8, which is 3 to the 1/2 power. Okay? The denominator, this one's 3 is not a perfect 6th. I can't rewrite 3. 3 is the smallest I can go. So that's going to stay the same all the way across here. 3 to the 1/6. And if you notice, the base numbers are the same. And they're being raised to some exponents. So what can I do with those exponents? We can subtract them. Okay, but bad news, I have 1/2 minus 1/6. They're not the same denominators. If I find a common denominator, the common denominator is going to be 6. 2 times 3, so 1 times 3 is 3/6, minus 1/6 is 2/6, not 4/6. 2/6, which is 1/3. Okay, the bigger number was on top, so this all simplifies 3 to the 1/3 power. Once again, it started in radical form, so I want your answer in radical form. It's the cube root of 3 would be my grand finale answer. And obviously on many of these, there's a little bit of work to show, so make sure you show your work. Okay, so a little bit of converting back and forth from fractional exponent form to radical form and vice versa, and then simplifying some radicals by doing fractional exponents. Thanks for tuning in. Oh, and use this sheet, before we leave, use this sheet as a reference in doing your homework. Okay, very good. Thanks for tuning in.